All right, recording this. This is 9th of September in AAD 367. AE or AAD? I don't know. Does it matter? What the hell does those even stand for? I don't, beats me. I still haven't figured it out. I've been here 11 years. Right, so you guys said you've heard of Zaha Hadid, right? Any of you been to Dubai? No? You have.
And to Jordan, where she also
So, Morpheus Hotels, the textbook example of sub-D geometry. That's what we're going to do. We're going to be looking at not modeling things with surfaces in Rhino or meshes. We'll be looking at sub-D geometry. Right? I think you're going to see a fundamental difference in how sub-Ds work compared to anything else you've done in Rhino, right? Now, if I was doing this with surfaces in Rhino, I'd try to make the box, and I'd probably take another box and try to subtract this out. Then I'd try to put some tubes through and cylinders and start to trim and split. And then I try to like fill it in round edges, right, that were already just sort of sharp corners. And I'm going to tell you that that process is a pain in the ass. It's laborious, doesn't work so well. For geometries like this, what you're better off doing is playing around with sub-D geometry. All right? And we are going to make something that's kind of like that. It'll be in the center of our planar pavilion. So we'll have something that's not planar. And we'll start as that with our core. We'll bring into Revit, and then we'll start to arrange walls, floors, roofs as planes around it. Right? So we'll make a planar composition. And then we'll have to reconcile and compromise back and forth between the sort of doubly curved goodness of some of this and the planar, straight, flat goodness of Revit. All right? Again, these have superpowers. Rhino's superpower, one of them is this. Right? One of Revit's superpowers is making floors, walls, and roofs, especially if they're planar, right? Especially if they're rectangles. All right, great. So let's see here. Here we are. Windows. That helps. Should have closed my email browser. Now I'm like, I see that red square and I'm so tempted to like just delete things away because I usually don't even read emails. Let's see. I'm just going to say new. Now, really, really interesting, right? Well, I don't know how interesting it is, but you'll see that when you go new and you start to get some templates, right? Really important, maybe not interesting, but important. We want to make sure that we're using units the way we use units. So I'm going to say large objects, and I'm going to use the units feet, right? Now, sometimes you just hit new and you don't really give a damn. And afterwards you go, shoot, what units are these, right? Especially if you're going to bring it into Revit later. So if that's the case, you can always go to, and this is where all the settings in Rhino are, Tools, Pull Down, Options. Okay. Holding it there for a minute. Tools, Pull Down, Options, all the settings you ever wanted in Rhino. You could more here than you can shake a stick at, including units, right? So you can see that there's a big long list here, and then you can drill down in. And I'm just going to double check and make sure that my model units are set to feet, right? All right. I'm going to hit cancel since it's already set to feet. You know what else I'm going to do? I'm going to go back to my options and go to grid and turn off this stupid looking grid. It's impossible to see anything on the projection with it on. I'll just maximize my perspective view. All right. When it comes to designing architecture, how many of you guys like to put down a thing of trace and line it up with a parallel bar, a T-square, your triangle, right? And what does that set you up to do? To draw what?
a line.
Lines, yes. What kind of lines and what kind of arrangement? Is this where
Parallel lines.
parallel lines going horizontal, sometimes parallel lines going vertical? What do we call that? Ordered set of lines going in different directions, creating cells. A grid, yeah. Yeah, exactly. I always establish a grid, man. I mean, if not, you're just killing yourself, right? Like, why make it difficult? Establish a grid. Design is about making rules and then Make a rule for yourself, a grid. Start off with it. Look, what do you see when you look down at this floor? Freaking grid, right? What do you see when you look at this wall? The grid. What happens when you like zoom out into Google Earth and you look at Las Vegas Valley? What do you see? A grid. There's some anomalies, right? Topo, you know, the grid starts here, but then later the grid started there and they don't quite match up, so there's a little bit of jog, right? You know, and Fort Apache comes Rampart, and then comes Durango, weird shit, right? But mostly it's a grid, right? Yeah, okay. All right, so that's what I'm gonna do first. And this is how I start any project, whether I'm on paper, whether I'm digital. I start with a grid, right? You know, it might have to do with structures, it might have to do with how to define rooms and spaces, right? It might be how to carve up a large shape into smaller shapes. Whatever it is, I mean, holy God, if you don't start with a grid, you're just like, it's like tying the hand behind your back, isn't it? Right? Yeah, of course. So I'm just gonna draw a grid. And what we're gonna do is we're gonna draw for our project what we call a 9-square grid, right? In other words, 3 cells wide, 3 cells tall, right? 3 by 3 grid. All right, and I'm gonna make these bays 15 feet each, 15 by 15, right? So 15 by 15 squares. So if I'm gonna do 3 cells, they're 15 each, I need at least 45 feet, right? Establish a grid. But you guys, when you guys draw stuff, right, with your parallel bars and just even sketching, right? Usually you draw a line and you extend it past where you need. You start before you need and you extend it past where you need. And you see that just a little bit of, just those little ticks of construction geometry. I do the same thing, right? You know, what I find is that oftentimes when I start with the grid, I usually end up having to expand it out anyway, right? Because the same grid that helps me order and organize architecture also helps me order and organize everything else in the site outside of the architecture, right? So the trees start to line up in the grid, and the paths start to line up in the grid. I don't just draw like curvy grids out of nowhere, curvy paths out of nowhere, right? I make things line up, right? I think about axes, right? Those are important parts of grid. Yeah. All right, so what I'm gonna do is I'm gonna start with maybe 55 feet long lines, as one does, 55 and a little tick mark. You can see that, I typed it in the command line after I hit the polyline tool. And it's telling me, okay, what direction? I have ortho turned on, so I can draw either X or Y. I'm just gonna click. There's a 55-foot line. Okay, again, sorry to make such a big deal. That was a huge buildup for a 55-foot line. All right. And I'll just copy it really quickly. Let's see. And 15 feet, I said, right? So I'm gonna make a copy of it, and I gotta make more copies of it. So I'm gonna say from last point, yes. From last distance, yes. Using last direction, yes. Click, click. All right, now I have 4 lines or 3 columns, right? Oh yeah. All right, now I can just make a simple copy of this and rotate them 90 degrees, right? And I get the grid in the opposite, get the grid lines in the opposite direction. And I don't have to like draw a bunch of stuff, right? But how do I rotate around this? I mean, remember, how do you find, let's say, the centroid between all 4 of these lines, right? If all you, like in geometry class in high school, all you have is a straight edge and a compass. That's right. We can draw diagonals across the furthest extents and get the centroid. In fact, there it is, right there, right? So if I say rotate, now what am I doing? I'm not going to any of these tools over here. I'm just typing some things in the command line, right? You guys do that a lot? Congratulations, now you know how to use AutoCAD as well. Because that's all you do in AutoCAD. R spacebar, rotate. A spacebar, arc. C spacebar, circle. L spacebar, line. PL spacebar, polyline, right? Okay. There's p-edit and all that other stuff and hatch, but you get the idea. All right, so I'm gonna rotate these. Rotate 1, 2, 3, 4, There's my point to rotate about, and I'll just type in 90. Wait, what? Oh, hold on, I forgot to hit copy. There we go. Rotate. Silly mistake. Copy, yes, there we go. There's the center point, 90 degrees,
and done. I'll just turn these off, right?
There, I have a nice grid. Really simple. Now, I'm doing this just because,
I'm just gonna show you guys what I'm doing. Let's see. Okay, so you guys get the idea. I'm not gonna belabor this too longer. Copy and 15 feet. And yes, yes, yes. And last but not least, let's draw a 55-foot long line in the Z. Let's move this up 5 feet, as one does. Move 5 feet. And we'll just copy this intersection to intersection. Oh, come on, what's going on? Oh, it's repeating last command with a move. My bad. Redo. Undo. Okay. There's too many undos here. There we are. All right, copy. Sorry about that. Even I make the occasional mistake, and I'm perfect, so, just kidding, of course. I'm also very modest. Okay, there we go. Now I have a nice 3 by 3 by 3 grid, right? In an elevation plan, I see 9 square grid. All right. You guys ready to actually start something real now? Sub D?
How many of you guys know what sub Ds mean? You do. Oh, good. Gotta start somewhere, right?
Perfect. All right. So, first things first, right? We know we have points and curves and surfaces and meshes and things like that over here. But what I'm going to do is I'm going to go to the sub D tools. It's a tab along the top, at least in the Windows side of things. There it is. You see now all the tools on the left-hand side change, and there's a set of tools on the top. Set these down so I don't get them all foggy. All right, so first and foremost, I'm going to draw a primitive. It's called a primitive sub D box, right? Now, if we were doing this with a surface, it would look like a cube, right? It'd look like a box. All the edges would be sharp and 90 degrees, right? That's what we'd expect. But I'm going to do this with a sub D. And remember, I'm doing a 3 by 3 by 3, so I'm going to say x count 3, y count 3, z count 3. Yours might say 2 by default or 4. You can always set those to 3 by clicking on them and typing in 3 and hitting enter. And I'm going to snap and snap and snap. All right, now, let's see what we have here. That is different, isn't it?
Some of you are like, wait, what? What the shit is that? What happened, right? Okay, I get it, right? What you'll notice is that we started off with, the requisite sort of 6 planes. They all intersect each other and trim each other out. But you'll notice that there are no edges, no corners, right? It's sort of all rounded.
And what's more is, I'll talk about the details of this later here, but I can select one of these faces and delete it away, and then suddenly the whole thing sort of puckers up around sort of a round hole instead of a square hole, right? Odd, no? How many of you guys are just like, yeah, no big deal, right? Just same old. It's like that meme. It's like the photo of the Earth and the photo of the Earth, and it's like before sub Ds and then after sub Ds, like nothing really changed. Okay, well, that ain't so right, because things are about to change dramatically. If you ever need to do geometry like this, sub Ds are the way to go. Now you don't have to download T-splines and install it as a plugin in Rhino, or move over to Studio Tools or Maya, but you can do them right here in Rhino, which is kind of nice. It's about time they finally instituted sub D geometry in Rhino. What's more is that I could just simply select faces, right, of the sub Ds, or I can select just its edges, right, or just its vertices, right, its points, and I can change those around, right? So I can sculpt it like it's a ball of clay. All right, what I'm going to do, again, just pay attention, don't worry about following along so much, because I can always redo this again and again. But I'm going to, what's a big thing I missed? I checked units, that's a good thing. stop what I'm doing and go back and rearrange layers, maybe label some, change layers around, things like that. So let's do that really quickly. I'll turn this to grid lines. I'll turn this to outer sub D. And I'll make layer 2 inner sub D. All right. And now I can turn these things on or off as needed, lock them, etc. Right? Now, the other thing I need to do is I need to select this sub D. Let's go back to my regular set of tools. Select this. Oof. Let's turn off the filters, the selection filter, so I can select the whole darn thing. There we are. And I can go to its properties, right? This sort of, this color wheel. And I can put it on the outer sub D layer, right? Okay. Now I can go ahead and turn that off, and I can turn this off, turn those grid lines back on. What I'm gonna do is I'm just gonna make another sub D solid cube in the center, right? So if you think about this, we have 3 by 3 by 3. We do have a center cell there, three-dimensional cell that I can populate with one of these as well. Sometimes it's a little easier to see this than others, but let's see. So I made the inner sub D layer the current layer, so that whenever I model something new, it's going to be on that layer. I've turned out the outer sub D so I can see what's inside. And go back to my sub D tools, go back to the same tool I used before, create sub D box, make sure my count is set to next to NY and Z, all to 3. And let's see here. Now, there's so many lines, it's kind of silly. But I believe it's this one to this one to this one. Yeah, there we go. You can see that we have a 9 square box in there. All right. Whoop, whoop. Now, here's what's really fun. I'm going to go ahead and turn everything back on. Maybe I'll turn off the grid lines. They're a little distracting at the moment. They're still there. I can just turn the layer back on, right? It's like a piece of trace I can take away and I can put right back on when I need it. But what I'm going to do is I'm going to set my view to ghosted so I can sort of see inside, right? So I can see both pieces of geometry. The outer one and the inner one that's nestled inside the other one, right? Yeah. All right, so next I'm going to use the bridge command. You guys watching? You guys ready for this? I'm going to build this up, and it's going to be so impressive or so not impressive. It's going to be funny. But I'm going to select this face and hit enter. That's the first face to bridge. I'm going to go inside and select the second face to bridge. All right, now it's telling me, okay, there's bridge options. Do I want to crease? No. Do I want to join things together? Yes. How many segments? I'm just going to leave this as default and hit OK. Right, now we have sort of an inside-out piece of geometry, right? The outside becomes the inside suddenly is the outside, depending on where you're cutting your section. And I'm going to do this 2 more times at this point, kind of at random, to sort of pick and choose based off of my own preconceived. Oops. Let me redo that. I always forget to select and then hit enter, and then select the second set and then hit enter. There we go. Now I'll just go to the other side, try to balance this thing out a little bit, maybe. I'm just going to zoom in now so I can see the inside of that other one. All right, look at that. Okay. Now I'm going to do this iteratively, so I'll just make a copy of this over here, just to go through the steps with you. Right. Now you can see how Zaha Hadid did this, right? Yeah, like she couldn't do these things before the computer. In fact, interestingly, back in the 80s, there's a whole subset of architects that were doing extraordinary things, but it was all on paper. And everybody would say, oh, it's really cool, but it's too bad you can't build it, like you can't possibly make it. They're called paper architects. And then suddenly computers came along, CNC machinery came along, BIM software came along, and now they like make everything, right? Like Morphosis makes these huge courthouses and museums. They are the establishment, one might say, right? Zaha Hadid makes large museums and hotels, hospitality, sort of things. So anyway, here we are. Now, we're not even going to stop there, right? But again, because I'm recording this, I'll go through the all the steps really quickly, and then we can do this step by step together, if you'd like. And we'll do it again tomorrow, okay? And take it a step further tomorrow. But now what I can say is, in my sub-D tools, I don't want to just select the entire sub-D. I just want to select certain portions of the sub-D, like some of the faces, all right? And remember, I did this just a minute ago. I selected one of the faces and left a little round circle hole. What I'm going to do is I'm going to go around these, and I'm going to select the faces that I want to delete and leave the ones that I want to keep. So I'll start with those and delete them away. Right? Now I'm going to go around this hole and do the same thing, holding down the Shift key so I can select multiple faces and delete. And do the same thing around this hole and hit delete. Ta-da. And now I can go around and get rid of all the junk here that I don't need, the rest of this shell, outer shell, right? Because this sort of inner vortex is what I'm really interested in. Now I'll show you an example of this either today or tomorrow, if I have a choice. But how many of you have been in Manhattan? Been to Cooper Union's campus? Seen the Morphosis building, right? Cooper Union. Right. That's the building we're going to look at as a precedent for this. Because it's a pretty nondescript box on the outside, at least, formally. But on the inside, it's truly extraordinary. It's a very introverted building, one might say. And that you have this sort of spiraling vortex of circulation in soft spaces, this sort of campus, if you will. But it's a vertical campus. This is a different scale and a different context, but still find it useful. Now, I was selecting faces, right? I could also select edges. Let me just go around and I'm going to start to hold down the Shift key. I'm going to be very deliberate, painfully so, in fact, I think, and just start to go around and take off some of these square edges. I'm just going to try to select them. Make sure it's selecting the right ones before I push the button on my mouse. Yeah, let's do that. And delete. Right? Now I've rounded that out. I've taken off some of those edges. You can see that the shapes inside sort of start to change. And I can do the same thing over here. Let's see, there's one. There's one. That just looks weird. So let's get rid of some of these and round this out a bit. Theoretically, there should be some rules to this, which ones you pick and which ones you don't pick. You can also do it by trial and error. That's one way of doing it. Get rid of some of those. Maybe get rid of this one. Not a fan of that huge bold job right there. And that one's weird. Yoink. All right. Anyway, here we go. Right now, that's a sub-D. All right. Now, of course, I can do lots of things with this. I can try to convert it back into a poly surface, right? A curved surface. Or I can quad remesh it. I'm going to offset it, right? Because let's say this is the outer surface for a space frame, and offset it to the inner surface for the bottom of the space frame. And then you're going to populate this with glass, just like we're doing with trusses and surfaces, right? Okay. So really quickly, just go through this process since I'm recording, but then afterwards I'll go back, we can do it step by step together, and we can talk about what I expect between now and Wednesday and now and Monday. All right? Make sense? Okay, good. Really quickly, what happens if I wanted to convert this into a NURBS surface? Let's see. I'll send it over here, and there's a tool for that, of course, convert to sub-D, where I can convert back to NURBS surface. And let's see, delete input objects, no, sub-D options. I'll just leave those as default and go ahead and hit enter. Now let me get this poly surface and let's move this out just so you can see what it looks like. Just move it out of the way over here. Let's take a look-see. First, it's a poly surface, right? So there's no like
great way of making a surface with a bunch of holes and sort of bifurcations in it, as in curves. Okay? Mathematically, they like to be sort of four-sided surfaces. And so what you can see is that a lot of those sub-D patches are now surface patches. In fact, if I explode this back into just 47 surfaces, you can see most of those surfaces line up with those sub-D faces, right? Now, I don't know how to make much sense out of these, so that's probably not the route I'm going to take for this exercise. Okay. But it's there in case you want to try it. You can always try to merge surfaces and try to make some sort of surface logic, but eventually you'll have at least 6 surfaces there. 1, 2, 3, 4, 5, 6. At least 6. That's if you're lucky, right? So I'll just go ahead and get rid of that. Another thing we can do, though, we can go back to our sub-D tools, and we can do what's called a quad remesh. The beautiful thing about a quad remesh is that now we have like a set of like oblong, strange, unequal sized quads and triangles on this because I started to lead edges away and things like that, based on how it was made. The fact that I had a small primitive and a large primitive, so smaller, denser grid and a larger grid. What we can do is try to even that out without losing too much fidelity of the actual geometry, right? So it'll approximate the geometry. It won't be exactly 1-to-1, but close enough for most purposes when it comes to architecture. In architecture, sometimes we measure tolerance in feet, not in like fractions of millimeters, right? So what I'm going to do is I can take that target quad count, I can leave it up, or I can take it down. Let's see here. And I'm going to say detect hard edges, convert to sub-D. If you have any creases or corners, go ahead and keep them, interpolate it. And let's do a quad count of 2,000 first, and I'll do one of maybe 1,000 so you can see the difference. There we go, there's one. Move it over here with the gumball. You can see that it's sort of cleaned it up, right? Now I have a set of quads. They're all close to the same size. They're not all perfect, right? But there's a logic to it now that didn't exist before. And let's say that all of these lines equal frames or edges of glass or struts in a space frame truss, right? Now I have to sort of think about the size. Maybe I'll go ahead and quad remesh this, but with only 1,000 target quad counts, so that those become a little larger. So I don't want like a strut and it's only this long. I'd rather have it be this long. I can easily span this, right? So let me just hit OK. Let's see what happens there, and let's compare it to here. A little different. Let's go dramatic now. And let's try 400. Something like that. Okay. That's substantially less dense, larger shapes compared to this first one over here with 2,000. Let me just convert these to wireframe really quickly so you can sort of compare the shapes, right? So you can see there's a size and density thing that we can actually have a little bit of control over when we do a quad remesh and sort of clean things up after the fact. All right. Now, I sort of want to like manipulate the geometry before I make so many edges and faces and points, right? The more edges and faces and points, the less smoothly I can sort of do overall sort of sculpting. But then it's a way to sort of clean things up after I have the shape that I want. Okay. Quad remesh is usually really helpful as well when you're dealing with meshes from point clouds, if you're like doing laser scanning, even with your phone, right? Sort of like, you can use triangulation or photogrammetry, stitch together a point cloud. Oftentimes, how do I put this? If you don't necessarily care about colors being assigned to each vertex for, let's say, a color point cloud, but you just want the geometry, then this becomes really handy to sort of clean things up in quad remesh. Get a nice clean mesh. Then it's really easy to transfer it into CAM software, then start to generate tool paths for, let's say, a CNC router or something like that to sculpt. So anyway, you can see that the differences here before and after doing the quad remesh with different settings. There we are. Okay.
If I go to standard and I just go to offset, let's see, offset. You notice that there's offset surface, there's offset sub D, right? I'm just gonna go ahead and offset this really quickly. Let me turn this back to maybe shaded or something. And I'm gonna offset this. It's gonna ask me which direction to offset it. To the inside, that sounds good. Distance, 1 foot. Solid, I don't want solid, no, I don't think so. And just hit OK, now I have 2, right? I have an offset of it, right? So now I have 2 surfaces I could play around with over this weekend after we talk on Wednesday. You'll know you'll have some ideas of what you can do with those, right? Using your grasshopper recipes. And you'll have fun, you'll play around, or you'll get frustrated and you'll throw the laptop against the wall. Either way, right? Run it over with your car repeatedly. But anyway, on Monday, you'll come back and we'll have a conversation, hopefully a productive conversation about, are you ready to move on? Or do I need to give you some quick help, right, to get you over the hump, right? Make sure you're doing things. All right, that's what this class is all about. I mean, look, not everybody's gonna model stuff like this. I get it, right? But you need to be exposed to it, right? If you don't believe me, just look around at the new football stadium or the new gigantic sphere, right? Double curvature is in. Not easy to make. In fact, it sometimes goes over $1 billion over budget, like the sphere. However, right? However, it's in right now, right? And sometimes it's useful, right? There are a number of reasons why you could maybe use double curvature. I think about some of the examples we see that are all around us. Think about your automobile. How many right angles are in your car per truck? Not very many, are there? Why do you have a lot of double curvature in a car? Aerodynamics, so performance in that sense. Why else? Why is a fender shaped the way it is? It's a structural performance issue, right? Like, look, if you take a piece of sheet metal and you don't bend it or warp it, it goes, it deforms, right? It deflects. As soon as you add double curvature, it becomes much stronger, at least in the places that you want, right? Now we even have shapes that'll crumple in the right axes too, to sort of absorb shock, right? Planes, computer mice, laptop covers, water bottles, Jesus. I mean, look, what's interesting about this water bottle, it's all about how much fluid volume you have, right? And actually, it's much more, how do I put this? It's less material to do that without right angles. You can still have the same fluid volume. Now, it's maybe not easier to ship and pack and fit into boxes that are also rectangles, and put it into the back of a truck, which is also rectangle, and ship it down a highway, which again, sorry, I touched the water so much, my bad. I just now kind of realized, like, I didn't touch anywhere near the sippy part. Right, so again, these things are, ask yourself, right, why is that shaped the way it is? You might learn something, or you might come up with a better solution than what's currently there. You put water bottles, there's a reason why they're curved. Right? First of all, if you don't have a really sharp corner, then when you drop it and dent it, you don't see dents over it. And you don't accidentally cut off somebody's foot. Right? But it's also, again, less material for the same volume. And in fact, that was the same ideal behind St. Mary's Axis, the Gherkin in London, right, by Norman Foster. That high-rise in London. We'll talk about it later. We're doing in project 3 when we're talking about surfaces, right? This idea that you can actually get the same square footage, gross square footage at least, but maximize on the volume cut down on the amount of volume that you have, that you actually need to sort of light and condition air and all that other stuff. All right, so anyway, there it is. I'll just quickly show you a sneak peek of what we're going to do on Wednesday, and that is, what do you think's next? Yeah, we're gonna put some grasshopper badassery into this. All right.
sometime today, hopefully. Come on, grasshopper, hold up.
You know, I always like a little bit of green to go with the red, right? Complementary color scheme. You guys talk about complementary colors, color theory? Why is this not? Some of you like had some knowing chuckles, like, yes, probably too much. I don't know. Sorry, let me just change this. Gosh, half of my day is just sort of waiting around, watching the computer do my work for me and waiting on it. Let's see, here we go. There, much better resolution. I don't know what was going on before. All right. Hey, you know what?
We can bring points from Rhino and Grasshopper. We can bring surfaces from Rhino and Grasshopper. We've done that a couple times. Curves. We can also bring in sub-Ds. Oh yeah, you know you can. In fact, there it is, right? So we'll make a couple of sub-D widgets since we have both an outside sub-D and an inner sub-D, right? The original master geometry, and then it's offset, 1 foot in. Right, so right-click, set one sub-D, Grasshopper disappears, exposing the Rhino interface so I can select that Rhino geometry. I'll do the same thing here, set one sub-D, and there we are. All right, so, and in fact, I can even turn that layer off, and we'll just take a look at the Grasshopper preview as we go. Now, the reason I did a quad remesh is because what we're going to do, and I didn't actually save it here, I can always go back and remesh it here in a minute, is I can go to Surface and I go to Sub-D Tools and I can get the Sub-D edges and I can get the Sub-D vertices. In other words, points and lines, right? Points and curves. And so let's see. There's all of its edges. There's all of its points. I'll copy and paste those and plug this set in as well. Now I don't see a sub-D offset, which is really unfortunate. I wonder if there's offset here yet. Offset surface, but I don't know if they can actually. Let me just try to plug it in a sub-D and see if it tells me to go to hell. It does, okay, it turns red. All right, so a couple of things I'm gonna do. First of all, this is referencing the sub-D over here. This one's referencing the sub-D over here, right? What I'm gonna do is I'm gonna go back and go to my sub-D tools. I'm going to redo that quad remesh. Let's see. There we go. Let's do this quad remesh business. Turn these back on. And target quad counts 400. That looked all right. Sure, why not? Delete input in objects. And I'll go ahead and remesh this. Okay. Now, technically, we created a new sub-D, so I just have to go back through and set that one again. And then this old one back here, I'm just going to delete. I'm going to offset this new one again. Offset sub-D. 1 foot, distance, solid no, okay. And I'll go ahead and re-reference this one in. Yeah, there we are. Now, for whatever reason, there we go. I just have to re-plug that in. Not sure why. There we go. Let's go. Look at that. All right, so now we have all the ingredients we need to make all kinds of interesting things, right? We know what we can do with points and lines. Okay, so let's try something interesting. Maybe what I'll try to do is I'll try to make a line that's 1-to-1 from each of these points on the outside, each of these points on the inside, to make sort of quick struts in that direction. That worked. Turn this off and we can see edges in green, plus the lines I just made. We're getting there, right? And then I can start to connect the dots around. We'll start doing more of that on Wednesday. I don't want to go too far here, right? Because there's a lot to do. It's not trivial to just sort of like play around with sub-Ds and make something that's actually decent that you enjoy and like, right? Okay, so cell sub-Ds. Let's just get rid of all of them. All right. You want to try this one more time, step by step? Just the sub-D part? Just making some sub-Ds and then bridging some sub-Ds? Then deleting some faces away, then maybe even deleting some edges away.
Yeah, why not? Okay, great. Beautiful. All right, so, well, we have plenty of time. Yeah, we do. All right, so I'm going to go to the sub D primitive, sub D box. Right? Just like the solids box, you know, making a polysurface, except of course we're making a sub D, so geometrically it's a little different. Right? And what I want to do, first of all, remember I have this 3 by 3 by 3 grid. And so I want to make sure that this thing is also 3 by 3 by 3. By default, yours might not say x count 3, y count 3, z count 3. Right? It might say 2 or 4. If that's the case, you can click on each of these parameters and change the value, right? Just make sure that's set to 3. And this one's set to 3, click, 3, enter, click, 3, enter. Right? And this, again, when you're ready to draw, it says first corner of base. I'll draw this in plan, and I extrude it up. Right? And there it is. Now I have that in the inner sub D layer, and I want to do the outer sub D layer, but that's pedantics, right? I can fix that here in a minute. Oh yeah, you know I will. All right, so now I can't just leave it there. I got to put it on the right layer. So I'm going to go ahead and select that sub D and go to the properties box and switch it over to outer sub D layer. Go back to my layers. There we are. Yay, all right. I'm going to turn that one off, and then in this thicket of lines and intersections, I'm going to try to make sure I'm making the inner one in that smaller inner cell, right? But with the same parameters, 3 by 3 by 3. Right, so there's the tool. It's called create a sub D box. I'm going to make sure X count, Y count, and Z count are all set to 3. And I just want to make sure that I actually snap to the right to the correct things here. Let me go to my O snap. Intersections are set. I'm going to turn off endpoints. I just want intersections. Why not? And I guess that's one. And that's one. And I could go down here and that's one. All right. And let me go. I can go back here and just double check things, but it looks like in both plan and elevation, it's in that center cell, right? Excellent. That makes me happy. I hate doing extra work, don't you? So let's see. What else? Oh, right. Now we have both inner and outer. We can bridge between them, right? Right. So we're basically making those sort of tentacle-looking things. Right? Yeah. All right. So let's do that. Bridging's fun. If you want to be a Zaha Hadid wannabe, the bridging is the way to go. All right. I'm going to start at the bottom, right? I like that sort of center, you know, like let's have something that's sort of structural that comes up from the ground, right? So that's why I'm starting there. And I'm just, again, I'm in my sub D tools here at that tab. I look for this tool right here, bridging, bridge, meshes, or sub Ds. And so it says, select the first set of edges or faces to bridge. I can do that. I'll do that here. So that's the first one, and I'll hit enter because that's the first set. And then for the second one to bridge to, let's zoom in a little bit, and select that one. Yep. And I'll hit enter or right click, and then I'll hit OK. All right. So far, so good? Yeah. Now, look, you can bridge between edges, you can bridge between faces, right? The thing is, if I select one face for the first set, I have to select one face for the second set. If I select one here and two here, it'll go, it doesn't work. You need to have the right number of faces for each set, right? Or same with edges. If I go around and do 4 edges around that face, and I do 3 edges around this one, it's gonna shut that down pretty quick. Just give me an error. Say, no, I can't do it, okay? So keep that in mind, right? If it's giving you an error, it's probably you trying to do something it's not capable of doing, it's user error, okay? And that's fine. What do we do when that happens? What's the first thing you do when you get an error? And it doesn't make much sense to you. You can hit escape or copy and paste that error into Google, along with the Rhino sub D, and try to figure out if someone's explained it. You'd be surprised between platforms that we're using just how many people have a lot of time on their hands apparently to post about these things and help people out. It's genuinely helpful sometimes. If you email me, what's going to be my first question? What error did it give you? What did it say? Right? It's not hard. I look at the command line, right? It tells me what it wants, and it tells me if it did it or didn't do it, and if it did or didn't do it, why it didn't do it, right? Okay, so, again, think these things through, right? I know it's really easy to get frustrated sometimes, and these things don't quite work. But try to keep an open mind. And some of you, I still mess up some steps with working with sub-D sometimes. I'm like, it's a completely different way of thinking when you have to try to filter, am I selecting a face or an edge or a point? It's a real pain in the rear, right? Or a real pain in the rump. Okay, so let me show you what this might look like then if, let's say, I selected 2 faces to bridge each time. Let's try this one and this one. Oh, and I'm going to try to select the corresponding ones on the smaller one just so that it doesn't get too weird and twisted here. There we are. Try to get back out there a little bit. See what I'm selecting. Oh, damn. I forgot to hit enter when I selected it the first time. Okay, this one and this one, then hit enter, right? That's the first set. Now it's saying go ahead and select the second set of faces. I forget to do that sometimes, see? And that leads to frustration. And when you don't know that that's the error you're getting, right, it can be very frustrating. Yeah, try to follow the steps. Try to keep achieve balance, and I'll hit enter, and there's another one, right? Okay, I'll hit okay. Why not? Sure. All right. I'll do one more. I'll go over again, let's say this way or something, try to get to something going on in this direction. Let's see. What we're doing, bridge. There it is. Bridge. I'll do this one to this one. Ah, damn. Same thing. First, then hit enter. I always forget to do that, even when I'm doing a demonstration in front of people. It's so embarrassing. Okay, and then that one. There we are. Okay. I recommend maybe stopping at 1, 2, 3, 4 tops. Right? Because eventually you have to start sliding planes into this thing in Revit. Right? Building walls, floors, some roof planes, etc. You guys will build roofs and they'll look like these shitty looking dip roofs. And then I'll show you guys how to just set the slope to 0, and then half of you will forget, and I'll get a bunch of these ugly looking green roofs. And I'll be like, no, go back in, let's fix that, because it just makes me want to throw up in my mouth when I see it. All right, so anyway, there we are. Next step, if you're ready. But again, if you look over here in these sub-D tools, over on the right, you can see that there's these filters. So I can filter, and it'll make it so that I can only select edges of the sub-D, or faces, or vertices, points of the sub-D. Or I can turn off the selection filter once I'm done doing that. So let's go to the faces, and I'm just going to go around here. And what I want to do is I want to select all of the things that are around the hole I just made. And I'll show you why I want to do that in just a minute. And go ahead and hit delete. And I get something that's fairly smooth around. Now, if I do this incrementally, what happens is I get to the end, and then oftentimes it leaves that point as a residue there. Right? So that's why I usually go all the way around, select them all at once. I delete them all the way around, and that way it just sort of doesn't remember that corner or crease. Okay. So if I go back around and select all of these, holding my shift key, then I can delete them all at once. Then I have this sort of smooth edge without any creases in the geometry.
How did you bring them back?
I just undid before. Control Z. So I can go down to this one, and I'm just going to select the faces around this one, holding down my shift button, my keyboard, so I can multi-select here. delete. There we go. Sound effects, always optional. You guys obsessed with like demolitions? Like, they're gonna demo the Tropicana soon, right?
Yeah.
Like, is anybody like there with like binoculars gonna watch this thing? Yeah, no. Yeah, I mean, right? Like, yeah, I mean, you're fascinated by how buildings stand up, and you sure as hell are fascinated by how they knock them over or make them fail, right?
Yeah, cause they do it perfectly, so they go
They try to.
implode, so
Yeah.
it doesn't destroy everything around it.
Yeah.
It's pretty amazing.
All right, so I'm just going around now and cleaning this thing up. It's like just the cleanup guy here at this point. I'm doing this just so we can see this thing in the round without all this other stuff here. And again, this is being recorded, so you can always go back and rewatch this anytime between now and next Monday. Okay, that was just deleting faces away, so I just am left with the geometry that I actually want. And I can also, again, I can start to select certain edges, holding down the Shift button on my keyboard so I can select multiple. Let's try to take the edge off this, what used to be a top edge. I accidentally selected the wrong thing, right? Don't worry, you don't have to unselect everything and start over again. You can just have the control key down, reselect it, and it unselects it, right? Let's see, I did this seam over there, so I'll do it over here. Then I'll go down this direction. Yeah, just pretend you're a sculptor or something and just going around trying to understand the shape of this thing and how you can begin to understand the relationship between the edges and oops, see, I just control click it to unselect it, and I accidentally select the wrong thing. That's what happens when I'm impatient. Trying to do this all in one turn. We'll see how well that works. Let's try that for now. Take away all those edges. It's starting to smooth out a bit.
So, can we just start with a circle inside the box?
You can, but then you won't have something that lines up face to face. And that's not really a sphere, it's more of just a blob that's informed from three different corners stretched in place.
But you're right, it kind of looks like it, doesn't it? Of course, if I wanted to get rid of some of that concavity, there, right? Now it inflects inwards. It's a little on the thin side though, I think, for this. Maybe if I did this one. Yeah, so you can experiment with that.
Now, as you do this, you have to undo if you don't like what you just did, right? So one thing I do recommend is maybe saving iteratively and making a copy off of like 30 feet off or 150 feet off in space. And so if you do something destructive, you can go back to the original one and start to play with it. You don't have to redo all the things from scratch. So there's ways to work smarter rather than harder. Or to, yeah,
So,
a couple steps away.
I have a question, and, I didn't understand quite some of these earlier. Is like you were talking about, if you wanna make this high D architecture and then high D, you couldn't actually build it, and now you can, and
Yeah, it's very difficult. They used to call them paper architects, right? These folks that did deconstruction, deconstructivism, parametricism. It really wasn't until the computers that they were built that they were able to sort of achieve these things at economy of scale that made them widely accessible. So now we have the Max Museum in Rome and you know, the Eugene, Oregon courthouse by Morphosis and those sorts of projects, right?
But, I mean, my question is, I understand that as far as industrial design.
Yeah.
But how is it that just simply building, like if I built this, and I want to make this into a gigantic library with branches up the side, how does that work out? Why did that change in engineering? Like, how does it work out that I could just draw and say, and an engineer could say, you know,
Good question, right? So the question is, well, why could you do this before the computer? You could. It would just take an enormous amount of like drawing power, like just throwing warm bodies at this night and day to describe it all and then manage it.
just made it.
And at the same time, when every piece is custom, right, it costs more. So you look at every strut in this, and each one's different, right? And so if you don't have equipment that can automate that, label it, and then GPS systems help you identify points in space where it all comes together, then it becomes very difficult. I mean, you could do stuff like this. Think about Aero Saarinen TWA terminal in JFK Airport, right? Big concrete thing. And the idea was concrete, this sort of plasticky thing, you know, material you can make just about any shape out of, as long as you can cast it, right? Or spray it onto, you know, stretched fabric, shop fabric, you know, shopcrete, those sorts of techniques. But by and large, they weren't cost effective. Now, are they cost effective now? It depends, right? What is the value proposition? In a place like Las Vegas or Dubai, it's the value is standing out and being the first at the gigantic sphere, the first at 2 towers that bridge with these weird sort of sub-D geometries or whatever it is, right? Not necessarily works out in Laughlin or, you know, Tempe, yeah, or Huntington Beach, you know.
But what about, Frank Gehry, he made all these, did that before?
And he did it with the software that Boeing used to create the 737, CATIA. Yeah, so he was one of the pioneers in bringing these sorts of technologies into architecture in the building industry and trying to make it all work. And in fact, at a certain point in time, not only did you get a paper set of documents for bid, but you got a CD. And certain tags in the documents that would say refer to the model. Which if you think about it, legally, you're assuming a lot of responsibility, liability, right? And so there's always this sort of head-to-head, right? This sort of arms race between how much control you want to have over the project and how much legal responsibility you want to assume. Right? And our lawyers say, don't. But we say, yeah, if we want to do this, we can work with the subcontractors so that we can win a bid and actually know what the hell's going on, right? We can share information, right? So this has been ongoing for a long time, especially as digital technologies have sort of put them back in the forefront. This idea of architects, you know, the term architecton, right? Tecton and tectonics came from the Greek maker, builder, right? Carpenter. We were master builders in the Gothic age, right? And slowly we've gotten away from being a sort of jack of all trades, knowing how these things go together, and leading construction to making a set, describing what we want, and handing it off to somebody who wins the bid, and saying, you're in charge of the means and methods of construction. Because we're not going to get sued when something doesn't line up. And what that means is that when something doesn't line up, then everybody's an adversary, and they're pointing a finger at each other and suing the pants off each other. So it's kind of a lose-lose situation. Now, if you think about why can we do this with water bottles but we can't do it with architecture? Architecture is a risk-averse industry. The building industry at large is risk-averse. When they say something's brand new, they go, oh shit, that's the R word, risk. And when millions, and sometimes even billions of dollars are at stake, right, the status quo oftentimes wins. So change happens much more slowly in the building industry than it does, let's say, at Procter & Gamble, where I better do a lot of R&D and invest a lot upfront to make the perfect bottle with the perfect shape
before I make 1,000 of, or millions of them that are all exactly the same, right? Buildings are one-off propositions, put together by teams that are assembled. Oftentimes people you've never worked with before, engineers from over here, local architect from over here, the GC wins the bid and they've never worked with them before, right? And lots of money is at stake. So the model itself is risk averse, doesn't like a lot of change. Right? To do something like this is really hard. It's worth it at the end probably, but it ain't easy. All right, anyway, that's enough because I think we're close to the end. I have a few more minutes for questions if anybody has any, but feel free to come on up if you have any one-on-one needs while I go ahead and finish the recording for the day.